Section 9.3 is factoring trinomials. So right now we're going to look at trinomials that are in the form of x squared plus bx plus c. What that means for our purposes is that we might have a coefficient in front of the x and a constant, but in front of the x squared will always be an understood 1. Later on we'll look at what happens when we put a different number in front of the x squared term and how that will affect our factoring. So for right now it's going to be things with just an x squared term at the front and then numbers in front of the x and the constant. First thing we want to do is look back at our foiling. So when we FOIL, and we just finished up this work, we're going to take two binomials and we are going to multiply them using FOIL. So the first is going to be x times x. The outside will be 5 times x. The inside will be 3 times x. And the last will be 3 times 5. So that's how I do my FOIL. I'm going to leave it in a little different form than we're used to for right now. But let's go ahead and look at our x squared. These two terms get combined. 5x plus 3x is 8x. But I'm going to write it as 5 plus 3 times x. And I'm going to leave this for now as 3 times 5. Now if you look at this, you notice that the number in the middle, and when we finish that off, that will be 8x plus 15. The number in the middle is made up of the sum of 5 and 3, and the number at the end is the product of 5 and 3. And those were the numbers that we started with in our factors. So remember, multiplication means taking the two factors and creating a polynomial. In today's lesson, we're going to start with the polynomial and learn how to go back to the factors. But this clue, the fact that the middle term is the sum of 5 and 3 and the end term is the product of 5 and 3, is what's going to help us with our factoring. So take a minute, pause, and write this down, and then we'll talk about it. Okay, to factor a quadratic trinomial. Quadratic means second degree. Quadratic trinomial. And a trinomial means 3 terms. Of the form x squared plus bx plus c, again, always a leading coefficient of 1 in this lesson. Find two integers, we're calling them m and n, whose product is equal to c, the last term or the constant, and whose sum is equal to b, the coefficient of the middle term. Then we're going to write x squared plus bx plus c as factors using this pattern. Okay, let's take a look at one of these. Let's do the one we just looked at a second ago. X squared plus 8x plus 15. So I want a number, two numbers, whose product is equal to c. So two numbers whose product will give us 15. So the only choices I think I have are 1 times 15 and 3 times 5. But I want those same two numbers to have a sum equal to 8. So 3 times 5 is 15. 3 plus 5 is 8. 1 plus 15 would give me 16, so that's not a good choice for me. So 3 and 5 are the numbers I want. I'm then going to write those factors as this pattern. So I'm going to write x plus 5 times x plus 3. And we just showed on the last screen that if I do multiply those together, I will get this trinomial. So that's how we go from a trinomial to the factors. Again, FOIL takes us from factors, multiplying them to get a trinomial. Factoring takes us from the end result, the trinomial, and tells us where did we start. All right, we're going to do a bunch of these. So let's look at this one, x squared plus 6x plus 8. Again, I want factors of 8. I'm sorry, my pen is not working well today. Factors of 8 that add to 6. So factors of 8. 1 times 8, 2 times 4. I hope you see that the 2 times 4 are going to be the numbers that when I add them, I will get 6. So they multiply to 8, they add up to 6, 2 and 4 are the numbers I want, and all I have to do is put them into x plus 2 times x plus 4. And those are my factors. If I want to check, I can always multiply. So if I take x plus 2 and x plus 4 and FOIL them, first times first is x squared, outside, inside, last, combining my like terms, and I do in fact get the trinomial that I started with. So my answer to this, my answer to factoring, is the factors are x plus 2 times x plus 4. So those are my factors. All right, we've done ones with all plus signs. Let's look and see what happens when we want to have a minus sign somewhere. So now I still need factors of 16, but now they have to add to negative 10. So factors of 16. I think clearly we can see that again 2 and 8 are going to give me 10, but they're going to give me positive 10. However, to get a positive 16, if I make this negative times negative, negative 2 times negative 8 is still positive 16, and negative 2 plus negative 8 is negative 10. So my numbers are going to be negative 2 and negative 8, writing them into my factored form, x minus 2, x minus 8. And again, if you want to check that, FOIL it out, you will get x squared minus 10x plus 16. So those are my factors. So if the last term is positive, I either need 2 positives or 2 negatives to multiply to get a positive end term, or a positive constant. If the middle term is negative, I need them to both be negative. Let's look at another sign that's a little different. So this time the last term is negative. So again, my factors of negative 12. First I'm just going to write numbers without signs. 2 times 6, 3 times 4. Now for these to multiply to get a negative 12, I'm going to need one of these to be plus and one to be minus. That's how I multiply to get a negative. My middle coefficient is 1. So take a look for a minute and see if you can figure out how to take one of these sets of numbers, make one plus and one minus, and so that when we add them we will get a positive 1. All right, hopefully you did 4 times negative 3. 4 times negative 3 is negative 12. Negative 3 plus 4 is 1. So again, moving these two numbers, negative 3 and 4, into my factors, I get x minus 3, x plus 4. Okay, now I've got two negatives. So this time again, factors of negative 12. Again, I'm going to start with 1 times 12, 2 times 6, 3 times 4. Since my product is negative, I need to find one plus and one minus that will add to negative 4. So I'm going to use 2 and negative 6. So my factors will be x plus 2, x minus 6. And anytime you want to check, we're going to take those factors that we found. That's my solution. This is what I'm looking for, factors. But if I remultiply them, x squared minus 6x plus 2x minus 12, that's my FOIL. Should be pretty good at this by now. Combining my middle terms, I do in fact get the trinomial I started with all the right signs. Okay, let's look at one more. This one's a little more complicated. Now I've got some variables in both spots. But hopefully you remember from when we did multiplication that if I can put a y at the end and an x at the beginning, I'll get this x squared y squared. I'm still looking at the same numbers. Factors of 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. Those are all my factors of 36. If you can find the right numbers right away, you don't have to write all this out. But I've got a plus 36 at the end and a minus for my sum. So I need 2 minus signs so that my sum will be negative, but my product will be positive. I'm going to choose -4 and -9 because they add up to -13. So I'm going to still start with x. And I'm still going to use my -4 and my -9, but to get that y squared at the end, I need a y for both of those. So those are my factors. We'll look at this a little more closely in class, but again, let's FOIL to do our check. So first, outside, inside, last. First times first, x squared. Outside, -9xy. Inside, -4xy, and last, -4 times -9 is positive 36 with a y squared. Combining middle terms, I get my original that I started with, so my factors are in fact correct. Okay? All right. When we factor, we are simply looking for the two binomials. Find the two binomials that are factors of the trinomial. So what we've been doing so far is factoring. We've been finding two binomials that are factors of the trinomial. Now we're going to look at how do we solve. When we solve somebody, we need to find, or when we solve something, we need to find the value of x. And to solve something, we need an equals sign. You can't solve an equation unless we have two halves with an equal sign. So this is going to change how we're doing things just a little bit. Before we go on, I want to look at something called the zero product rule, because we're going to need this for our solutions. So the zero product rule says that if we have any two numbers or any two things, a times b, that equal 0, either a equals 0 or b equals 0. When we multiply two numbers together and we get 0 for our answer, it is impossible to get an answer of 0 unless one of the factors is 0. Okay? So when we have our binomials, x plus a number equal to 0 now, one of these has to equal 0. So either x plus a equals 0 or x plus b equals 0. To solve, I'm going to subtract a from both sides and subtract b from both sides, and those will be my solutions. These are my factors. These are my solutions. Let's do some with numbers and things will make a little more sense. Okay, so let's have x squared minus 6x equals -8. To solve this, I am always going to set it equal to 0. So I'm going to add 8 to both sides. Now I'm going to factor the left. Factors of 8 that add up to -6. I'm going to use -2 and -4. So my factors are x minus 2 times x minus 4, and those equal 0. So now I can solve. If I don't have an equals to 0, I can't solve this. So 2 factors equal to 0 means that one of these multipliers has to equal 0. So x equals 2, add 2 to both sides, x equals 4. And my solutions are 2 and 4. Remember again, my factors were x minus 2 times x minus 4. My solutions are 2 and 4. If I check these back in my original, which was x squared minus 6x equals negative 8. If I check 2 squared minus 6 times 2 equals negative 8. 4 minus 12 equals negative 8. That works. If I check 4, so that was checking 2. If I check 4, 4 squared minus 6 times 4 equals negative 8. 16 minus 24 equals negative 8, and that works as well. Okay, we got one more problem to look at. Whoops, let me clear the ink here. So these are the steps. Let me go ahead and put them up, and you pause and write them down to solve an equation that's in quadratic form. And remember again, our quadratic form is x squared plus bx plus c. All right, so solving an equation in quadratic form, write those steps down. Okay, whoops, there's one more step that I forgot. Got them all? Okay. So, our last problem. The length of a rugby field is 52 meters longer than it is wide. If the area is 8,160 square meters, find the dimensions of the field. So first of all, I know I need an area formula. Length times width equals area. I also know that the length is 52 meters longer than the width. So I'm going to use W for my width. See if you can think of what expression I'd be using for my length then. So the length is going to be 52 plus W. And to get area, I've got to multiply these together. So length, which is 52 plus W, times my width equals the total area, which was 8160. If I distribute 52W plus W squared equals 8160. This looks like a quadratic form to me. I've got a W squared and a W and a constant. I'm going to put these in order on this side, and I'm going to subtract my 8160 to set it equal to 0. All right, I'm going to give you a little hint here. 8160 has a whole bunch of factors, and I need to find 2 that will add up to 52. I'm going to give them to you. We'll talk in class about the best way to find these with a calculator. So my factors will be W, and I need a minus and a plus here. W minus 68 times W plus 52. All right, finish this off. Get me a solution. We've done the factoring, and I will see you in class.